In this video, we are going to understand the in-order traversal mechanism in a binary tree with an animation in this visualgo.net website. So, in this screen, you can see a binary tree where each of the data item is basically an integer, and we will try to visit all the nodes of this binary tree utilizing in-order traversal mechanism. Now, in in-order traversal mechanism, always remember the order. That is, first you have to visit the left, next you have to visit the root, and next you have to go to the right. So left, root, right, or you can say it left, then parent, and then right also. So we will use the term root and parent interchangeably in this video. And in this video, I will use two different terminologies and two different type of colors to understand the facts. The first one is traversing. So traversing the node and visiting the node is not the same. Traversing will be depicted using this orange outline, which means that all right, the node have been traversed, so it have been touched once or something like that. But visiting means the node have been explored, and there is the data item have been printed in particular fashion in maintaining the actual order. All right, so let's try to, and this, when it is visited, that will be depicted with a solid orange circle. So traverse means it will be depicted using just an orange outline, whereas so visited means it will be depicted using a solid orange circle. The color of the nodes will, or the vertex will change to orange. So let's start exploring this. So now first, the traversal starts with this root node, which is 41 here. So the first step is, if this node is null, then it should return. So well, 40, it is just like for the empty tree. Well, of course 41 is not null, so it will go to explore the left hand side first of this 41, of this root or of this parent. So let's move to the left, means it will move to 20. So well, it will move to 20. So just check this caret symbol, red color, that will tell you that where the program control is actually moving in each step. So it moved to 20. Now what will happen? Now you have to remember one thing. Again, remember the traversal order: left, then parent, then right. So in every node during the traversal sequence, it will traverse one node, and while traversing that node, it will find out if there is anything remaining in the left or not. If there is, it will simply traverse to the left child, and in this way it will move forward. And when there won't be anything to explore, when there won't be anything anywhere to move forward in the left direction, then it will visit the node. So let's see what happens. So 40, we traverse from 41 to 20. Next, so 20 has a left child, so let's move there, that is 11. So now the program control is at 11. Now in 11, is there anything in the left child, in the left hand side, or as a left child of 11? Well, no. So that means you have to visit this node, and it is depicted as a solid orange circle. So 11 is visited, and then what you have to do after visiting this, then you have to go for a right in-order traversal. You have to check whether if there is anything in the right hand side of 11. Well, there is nothing. So what to do? We can directly backtrack to the previous node like this. So here it came. Now, after it came here, it realized that, well, the node which are in the left hand side, that is explored already. So according to the in-order traversal order, the left node have been visited. So I have to visit so left child have been visited. So I have to visit this current parent. So 20 is visited. So this node 20 have been visited here, and now and it is represented with a solid orange rectangle. Now after 20 have been visited, now it is time to explore whether it has anything in the right hand side or not, because left is visited, parent is visited. Now let's see whether there is anything to visit in the right hand side. Well, there is. So let's move to 29. Now in 29, after coming to 29, again you have to check whether there is anything to visit in this left hand side of this node or not. Well, there is nothing. So visit it and then check whether there is anything in the right hand side or not. Well, there is 32. So move to 32 again. And after coming to 32, then again check whether it has any left child or not. And since 32 does not have any left child, visit this and then check for any right child or not. And now since 32 is a leaf node, it does not have any right child also. Just backtrack all the way to the root which was not visited. Now after coming to this 41, you realize that, all right, the left part of this entire 41 have been already visited. Everything is solid orange now. So now I can focus on the right hand side or the right subtree of 41. So let's move there. So now we came to this right subtree, I mean the right child of 41, that is 65. I moved there, I traversed there. And after traversing to 65, I found that, okay, 65 again has a left child. So first I have to traverse there. So I traversed to 50. So in 50, I saw that, okay, there is nothing in the left hand side. So visit 50. That is orange, solid orange color. So 50 is visited. Now 50 does not have any right child also because this is a leaf node. So backtrack to 65. And in 65, as you can realize that its left is already visited, so it's time to visit the parent. So 65 is visited, and after 65 is visited, now it's time to look back to its 65's right, which is 91. So traverse to 91 and take the program control to there, and after traversing to 91, again check whether it has anything in the left hand side or not. Well, it has. So go to 72, take the program control to there, and well, 72 does not have anything in the left, so visit 72 in here, and then look for if there is anything in the right direction, in the right side of 72. Well, there is nothing. So just take the program control back to 91, and since everything is explored in the left hand side of 91, you just visited 91 and marked it with the solid orange circle, and then look at the right hand side of 91 where I found there is 99. So let's take this program control to 99, and in 99 I found that, well, there is nothing nowhere to go in the left hand direction, I mean the left hand side. So visit 99 and then start looking for right direction. Well, since 99 is leaf, there is nothing to go in the right direction also. So it's almost done. So just backtrack to the final root node. And this is how you can do the left hand, so the in order traversal of a binary tree.